Hello, everyone. Welcome to the next episode of the Hewlett-Packard Labs podcast, From Research to Reality. Today, we'll cover Discover. We'll provide you some videos from the last year's Discover, and we'll give you a little bit of preview what will happen this year. Hey, Kirk.
Hey, Dan.
Welcome back to Labs.
Glad to be here.
So I hear you're going to Discover again this year?
Discover again, 2025, Las Vegas in June.
So what is Discover?
Discover is the biggest all HPE event we have every year. Customers, partners, our team members, us here at Hewlett-Packard Labs, all descending on Las Vegas for a week where we get to join community, to share, to learn, to explore all things Hewlett-Packard Enterprise.
So I can see why it's important for HP, but you've been going forever since I've known you. Why do you go over and over again? There must be some good things for you too.
And for me, it's always meeting the people who use our technology. It's one thing to be clever, to have that next patent you get to put plaque on the wall, but when you get to meet someone who's making a difference in the world because of the technology that you created and now have delivered, and then you get their often unvarnished feedback about what worked and didn't work, most valuable week we can have every year. And I think it goes for us at Hewlett-Packard Labs too. When we're looking out farther and farther out than perhaps the business teams, getting that first effect, that first measurement, maybe just get that inkling from one or two discussions, and it'll set you on a line of research that might be very valuable in a decade or more.
You answer my next question as well, but I'm sure there's a little bit more to it. Why is Labs at Discover? I understand for businesses, products, and all of that. But why Labs? Why do customers care, and why do Labs care?
Yeah, so a lot of times customers are there and our partners are there at Discover to learn what is happening right now. But they always also want to know what's coming next. What do I need to prepare for? We're used to, things now. If we think about Discover, back in 2015, things that we're going to show off would have not even made science fiction magazines back then, except for we had the Labs team that was thinking about far ahead. I always think I've done my job when I go to Discover and I'll meet someone and say, 5 years ago, you gave a tech talk here at Discover, and it turned out it's exactly what I needed to know. So being able to give people, it's speculative, we're not always right, but I think we do have that line, we have that ability to look forward, and we're getting there to prepare them so they can think about, what do I need to do today and tomorrow, but what do I need to do in 3 years, in 5 years? What should I anticipate in 10 years is going to be at Discover? What's going to be at Discover 2035? Well, I think you'll learn by talking to the Labs team this year.
So I've seen you over and over, some masterpieces of your discussions with customers. Give us a little bit of preview. Are you going to give any talk over there? Or?
Yeah, so I have a tech talk, and it is the Quantum Brutalist, and it is for us to just be brutally realistic. Quantum has been such a fascinating technology, but it's also been 40 years since Richard Feynman said it better be quantum, and we still don't really have an outcome in society that we say, that's because of quantum. We can say that for AI. We can say that for computing. We can say that for a lot of other technologies. Quantum still hasn't arrived yet. And we have been making progress, but we really want to just be, how do we map that out? How do we give people a timeline, not a series of breakthroughs, but actually a timeline measured in units of time? How do we measure where this is going to be an important technology? Where is it going to mean something to the enterprise, to the scientist, to the engineer, to the financier, you can have those conversations where you talk about investment, or maybe give your kids a recommendation what they should be thinking about studying in school.
Thanks, Kirk. See you in Las Vegas.
Las Vegas.
Hey, Gaurav.
Hey, Dan.
So I know last year you prepared the demo for Discover. I've seen you preparing for this Discover for this year. Tell me a little bit about it.
So we are working on a demo that's like better than the last year. We had like a small frontier thing last year, and now this time we are adding more stuff around it to showcase how electricity is supplied to such supercomputers and things like that. And we are adding the VR stuff to showcase how it would look for our prospective customers and things like that.
I saw you playing with a little bit LLMs. Is that part of it too?
That would be part of it. because those would be some applications that the customers would use on these big supercomputers. So yes, that will be part
Is
of
this
it.
what you do every day, or it's exceptional?
No, it's not what we do every day. We do much more than that. But working on demos for Discover is a lot of fun because we get to create these small models that one of our colleagues actually makes them at home. And it's a lot of fun putting things together and making things work.
Hey, thanks, Gaurav.
Thanks.
Hey, Grace.
Hey, Dan, how's it going?
Welcome back to our
Thank you.
podcast.
Thanks.
So I heard you're going to Discover.
Yep,
This is your first Discover.
first Discover.
So what are your expectations from this Discover?
Somebody told me it was like drinking out of a fire hose or burning a candle on both ends, but it's a blowtorch. Just heard that one. So I think it's going to be really exciting and, lots of energy and yeah.
So what kind of candles are you going to burn over there? What are you going to talk about?
What am I going to talk about? Well, we're going to be talking about our research building quantum supercomputers. So, talk about HPE's role and how we can kind of make the utility scale quantum computer, right? Bring the research of quantum computing, out of the research and into useful real world applications.
And you've been a couple of years here or more at Labs.
Yeah.
What do you see as the biggest value that Labs is bringing to Discover?
I think that Labs is hugely important because we're thinking about technologies that are, going to hit the industry in 5 or 10 years. And, technological innovation is hugely important for a company like HPE. And, just thinking about our work, at least, what does the future of supercomputing look like? Well, it's, heterogeneous and it includes things like quantum computers. So, having this fundamental research work or the research that moves from the fundamental into the applied and industry, kind of bridging that gap, I think it's crucial.
And I have a little personal question without giving too much. Do you promise to keep on coming here instead of sending your avatar?
I don't know. Depends on how it goes. Pretty nice to just, send the LLM out.
Thank you very much. Thanks for
Dan.
coming.
Yeah.
Hello, Ted.
Hey, how you doing?
So, Ted, you have been to Discover many times.
Several times, yeah.
What is Discover?
Well, for me, Discover is the best way for me to meet as many customers as I can in a very concentrated sort of way.
And you now work at Labs.
Yeah.
Why is Labs going to Discover? We don't have direct customers, but there must be some good reason.
Well, I can't believe in technology that we develop unless it's focused on what customers need. And it's very, very hard to extrapolate that. And so it really helps to have focused time with customers. Last year, an engineer from a major car company spent 6 hours with me talking about how they move data, how they store it, how they build cars, how they develop them. It's not like you build one car, sell one car. It's millions of designs at once. And so their data problems are really intense. And I learned a huge amount. And I learn every time I go to Discover.
So when you go there, what do you do other than talking to customers? Do you present? Do you showcase?
Yeah, a little bit of everything. And last year and this year, I'll be speaking largely about security and some of the research I've been doing. Last year, the title was, We're Doing Security All Wrong. Everybody's doing security all wrong. And this year, the title is, Everybody's Still Doing Security All Wrong. Because there are major, major complexities that we're imposing on users. We need to fix that. We need to make it correct by default.
Excellent. Thanks for going there and representing all of us. Hey, Paulo.
Hey, Dan. Good to see you.
You've been a fixture at Discovers. Why are you going there? Why is it so important? And what is Discover to start with?
Well, Discover is the premier customer event sponsored by HPE, where we're getting together all our technologies, products, and innovation, and we're showcasing it to most of our customers, like tens of thousands of people attending Discover every year.
So when you go there, what do you do?
Well, usually we speak to customers, we connect with our colleagues in other parts of the business that we don't always see, and most importantly, we showcase our innovation from our research projects.
And we in Labs, we do research, so there's no direct connection to customer, only indirect. So why is it important so much to have labs presence at Discover?
Well, the customers usually want to partner with an IT provider that has visibility into the future. So for the customer, it's extremely important to know where we see the next frontier of information technology. And so having a glimpse at the key technologies that we're pushing in labs is a fundamental component of a relationship with some of our important customers.
But this year, neither you nor I are going. So.
No, well, we have to, rotate and, bring up the new
Fresh
generations and exactly fresh blood. And it's a great opportunity for the rest of our team to get exposed to a great community and event.
Yeah. Thank you very much, Paul.
Thanks, Dan.
Let's look how things were at Discover 2024.
In this demo, we're taking a holistic view of data centers from a life cycle perspective. So from the configuration of data centers, how we think about what equipment we should place in the data center that's most energy efficient, to its operation, to ultimately scaling it out into a global distribution. Dayan's been doing a lot of work in this, and so Dayan, why don't you tell us about some of the stuff you're working on?
Yeah, so we first start with very detailed performance evaluation. If you don't know how variable your results are, you're not going to get good results. So that's at the core. Then we build the whole stack for digital twin to be able to monitor everything and then recommend actionable activities. We also did a lot of predictions work. Prediction is very important for us because using predictions, we're able to know where to send the load. We understand seasonalities and things like that. Also, as Colin was pointing out, we take holistic view. We look at geo-distributed data centers so that in case that, for example, it's afternoon in Silicon Valley, we can ship some of the loads to the East Coast, but some loads won't do well on the East Coast because it will take more data to send it. So knowing and understanding this behavior is really critical. Because we came here, we were also showing various concepts, such as this little frontier, because we started with the most pressuring demo of the frontier, which is shown up there. And this is really replica. My colleagues in labs, they 3D printed this, populated with Raspberry Pis. And then here, using Grafana, they're showing energy, performance, memory on the left side, and on the right side, what they do is they predict. So in that way, you can use this prediction to make all kinds of decisions.
Ultimately, what we're trying to do is build and operate data centers in a way that uses resources most efficiently, whether it be carbon, water, energy, and thereby make a data center that's much more sustainable as we move forward into the future with AI.
And this is all assuming that energy is constrained. We're also working in making much more affordable energy. For this, I will pass you to my colleague, Paolo Faraboschi, also known as Faraboschi, who will be talking about fusion way of generating energy. Paolo.
So this work is a collaboration with the US Department of Energy, and we're applying AI machine learning to improve the yield of a fusion experiment. So fusion experiments are really complicated. Scientists have a finite budget of energy when they're trying to ignite a small pod of fuel, and they have to come up with a very complicated shape of the curve. So what we're trying to do is use AI and machine learning to effectively produce an optimal schedule and provide recommendation to the scientists so that they can choose a better instrument. So it's an example of using AI machine learning for scientific application, but while keeping the scientists in the loop, because that's still very important, so that they can apply their knowledge, but at the same time being more efficient by removing and automating a lot of the groundwork that would need to do no matter what.
Hey, welcome. So this is our project about animal tracking, and animal tracking is this ancient art of looking at these footprints, observing them, and figuring out which species of animals they actually belong to. And this, unfortunately, is a dying art. It helps a lot in wildlife conservation efforts, but because of urbanization and things like that, fewer and fewer people are interested in it. And since it's so crucial for wildlife conservation efforts, Our tracker, our collaborator in South Africa from the Tracker Academy, came to us with this problem: that is there any way we can preserve this ancient art of animal tracking before it vanishes off the face of the earth? And so we were like, sure, if you can send us a bunch of images of these footprints, we can build AI ML models that can look at these footprints and decipher the unique features of them and then tell you what species they belong to. And in the long term, once we have enough data, we can actually look at larger migration patterns, more advanced analysis. And once we do that, obviously, that is a really crucial tool for wildlife conservation efforts and helps them understand animal behavior patterns and so on. And this is, we've developed an app for this that can hopefully will be released publicly soon because a lot of it depends on data collection, and hopefully there are enough experts around the world still who can download our app and get to helping us collect data, which will make our models better and ultimately help wildlife conservation efforts. Thank you.
We're here at HPE Discover at the Hewlett-Packard Labs Pavilion to talk about our work in integrating quantum computing into tomorrow's HPC data center. We've been working over the last several years on a road to quantum computing. How do we pull in the power of quantum computing integrated into the high-performance computing data center, integrated into the high-performance computing algorithm, and integrated into the professional capabilities of today's HPC programming team, and looking forward to those quantum-native algorithmic experts of tomorrow. With me is my colleague, Masood Masheni, and he can explain one of the very interesting research results we're working on right now, how to knit together QPUs to solve really important problems.
Okay, so people have been envisioning quantum computers to solve certain really big problems like discovering new drugs, simulating complex quantum systems for discovering new science in chemistry or condensed matter physics, and also breaking the crypto system. For many of these applications, you need tens of millions of qubits, and some of the simulations could take months or years. And we don't have that technology. So where we are here, we have tens of qubits, maybe hundreds of qubits. They're noisy, and so the processor are small and unreliable. So how we can get from here to here, this is what we are trying to do. We do large scale, small and large scale simulations, digital simulation of quantum computers, and this is going to give us some insights into the difficulty of the problem, but the main thing is we break down a problem into pieces and tackle it by various different quantum processors. So this is kind of a simulation we've done with NVIDIA for 40 qubits on SC23, and this is going to be a small piece of the bigger picture, that we break a problem into pieces, we allocate it to different quantum processors. So it's going to be a heterogeneous architecture of various quantum processors with HPC. So basically what it works is that you start with the ansatz of a system, you break it down into pieces, you allocate it to different quantum processor. You have a quantum machine learning to learn the optimal circuit to run this. And then you have an outer loop, classical machine learning to learn the architecture for this. And we showed with these tricks that we can simulate certain systems with orders of magnitude improvement in sample complexity.
There is a huge interest and hype around artificial intelligence, and we've seen a lot of people interested in that in Discover. But our question is, will we be able to keep up with the energy consumption that is going to require in the next generation, especially when it comes to edge processing, when you may have a constrained number of watt that you want to spend for your computation? Can we scale that with the current model? We really think that what you have to do is changing the underneath physics of the hardware and changing the way you do computation to make it more efficient for AI. We have different tools for that. We are looking into analog in-memory computing, so do computation within the memory without getting data back and forth continuously, and optical computing, where you're going to compute in the photonics domain at the speed of light. So we have developed a number of test chips for demonstrating this concept. You can see here under the microscope, we'll have a photonics chip that is able to do matrix vector multiplication, which are at the backbone of machine learning workloads. And your data can already come in the photonics domain. You have your fiber optics going into the your data center, and you can analyze the data on the fly without even converting that back into the electric world. We have over there an analog computing accelerator based on in-memory computing concept, where by just reading the memory, you are able to do the computation. So instead of doing that back and forth continuously, with just one single memory access, you can get the output of your machine learning model. These results in 10 to 100x improve energy efficiency compared to conventional digital accelerator, and we really believe that is the way to go, especially when it comes to edge processing.
And now let's peek into Discover 2025. Hey Pedro.
Hi Dan.
So you helped us last year prepare the demo for Discover. What was it showing?
So last year we were showing a model of the Frontier supercomputer scaled down that can fit in your hand, and it had Raspberry Pis running some synthetic workloads in there. And we were showing how we can build digital twins and dashboards to see what's going on in these little computers, trying to showcase how it can happen in the real thing.
And it worked extremely well. I have so many people come taking selfies. And because you did the job so well last year, you're rewarded this year by going yourself. Are you going to show the same thing or are you going to improve it?
Well, we're hoping to make it a little bigger, still fits in the palm of your hand, but now we're going to have a wind turbine set up, and we're going to have solar panels, and we're going to have a SMR models there to showcase what we can do in terms of distributed energy resources. And on the software side, we are working on new dashboards for these resources, as well as ways of talking with the data and with the digital twins that are running using LLMs.
And what could these digital twins do? Can they help us with understanding sustainability, security, etc.?
They can do all of that. We hope that through centralized monitoring stations, you can follow what's happening on the data center, on the energy grid, and all of these aspects that you mentioned. So security, sustainability, and the distribution of the energy consumption on the system, but also we're looking for ways of detecting intrusions or perhaps tampering with these energy sources.
Thank you. Thank you very much for doing all the work for us. This year, I'm preparing a package for mobile recording so that you can do your own recording at Discover.
That's great. Thanks, Dan.
Join us at Discover 25, Las Vegas, June 23rd through 26th.